Hello everyone, my name is William and today we are going to solve this. What kind of equation do you call this? Radical and rational functions. And today we're going to learn about the meanings like MPV, behavior of MPV, and we're going to know how to graph this together. Shall we go straight into the video? Let's go. Okay, now the first thing that we're going to do is to simplify this equation as far as that we can do, okay? Okay, so what we're gonna do, okay, I'm just gonna solve it from here so we have more space, okay? So let's try to first factor out this cute equation. Okay, so it is -4 plus 1, right? Because if we add them together, it's -3, this is -3, and we multiply them, we get -4. So which is -4 over x minus 4 x plus 1, just normal factoring until now. Okay, our goal is to know how to graph this cute function. So what we're gonna do is just cancel this out, 4, right? So we know that this 4 is our POD, point of distribution. Okay, and if you simplify it, it is y equals, okay, I'll explain this a bit further later on. Y equals 1 over x plus 1. And this is our final graph. We need to graph this equation into here. Before we write this, we're going to solve this. We're going to graph it first. So what we're going to do is we're going to plug random into the x, where this x is located, and find out the value. But before that, most importantly, you guys must know this. Before we do the graph, one thing that we must know is, you guys might know this already, is vertical asymptote and horizontal asymptote. If you don't know the vertical and horizontal asymptote, we can't go any further at all. So what this means is that vertical asymptote, if there's px and rx, or q, let's say qx, it doesn't really matter. Okay, we have that px in the numerator and qx in the denominator. Numerator, denominator. What we're gonna do is factor of px is x-intercept. Factor of qx, which is located in the denominator, indicates as vertical asymptote. You guys must know this because this is a very important rule that we must know in order to graph, right? Then what about horizontal asymptote? This is x-intercept. How do we figure it out? So this time, horizontal asymptote indicates the number of degree. Okay? Looking at this, you guys know that this 2, 1, which is greater, px, which is numerator side, right? Okay, so when the degree is higher on the numerator, 0 horizontal asymptote. This is a very crucial rule that we must know. But what if the denominator is smaller? Oh, let's say, no, not smaller. What if denominator is bigger? What if the degree in the denominator is bigger than numerator? What do we do then, right? What do we do? This means that horizontal asymptote indicate as y equals 0. What this means, looking at this y graph, it is 0. Okay, so you guys know this is 0. So, okay, so, but what if they have the same amount of degree, like 1 degree over 1 degree? What do we do? This time, we look at the number of coefficient. Number of coefficient, which is 2. This is 1, right? What this means is horizontal asymptote is 2 because 2 over 1 is 2. Make sense? Okay, now let's go back to the question and find out our value of vertical asymptote and horizontal asymptote by looking at this equation right here. Okay, so for the vertical asymptote, remember I said vertical asymptote indicates the factor of qx, which is -1. So vertical asymptote is -1. Sorry. Vertical asymptote is -1. What about the horizontal asymptote? What do we do? Let's just say there's imaginary x and there's a 0 degree, right? And look at this x. How many degree do we have? There's invisible. There is invisible number 1 here. Then it's 0 over 1, just looking at the degree. What is it? 0. What this means is that when the denominator is greater, right? When the denominator is greater than the numerator just by degree, what do? Y is equal to 0. And this is our horizontal asymptote. Make sense? Okay, then we can easily just point it out. And also one key thing that I really recommend you guys to know is that you guys know it's v, x, and y when we point something, right? This x and y is same thing as vertical asymptote over horizontal asymptote. I really like to memorize this as vaha, which is vaha, right? So this vertical asymptote indicate as -1, and the ha, which is horizontal asymptote, is 0. And this is also same thing as x and y. So what we're going to do is indicate where the asymptotes are. Let's first do vertical asymptote. -1 here. Horizontal asymptote, 0. So what we do, very easy, just draw a straight dotting line here. So what this means is that when we have a curve, like for example like that, it can never go over this horizontal asymptote and this vertical asymptote. Looks a bit messy, but you guys know what I mean, right? Okay, so coming back to the original equation, very easy from now on. What we're gonna do is, oops, what was it? Y equals 1 over x plus 1. Okay, so we're just gonna plug random numbers into this x. For example, like 1, 2, 3, -1, -2, -3. You guys know this is all x, right? What happened if I plug 1 into this x? What do we get? You guys can just use calculator for this one. It's 0.5. Same thing. We just plug the numbers where this, okay, you guys know this x doesn't exist, so don't get confused. Okay, so what happened if you plug 2 in this x? We get 0.3, infinity. What about 3? 0.25. What about -1? We don't get anything. -2, -1. Very simple thing. We can just plug it in. -0.5. Okay. So now what we're going to do is just plug this exact same value into our graph. Okay, so I'll use this blue pen. So when it's 1, it's 0.5. When it's 2, it's 0.3. When it's 3, it's 0.25, which is a bit lower than this. And we can't go below this x-intercept because horizontal asymptote is 0. When y is equal, this y is equal to 0. Sorry, okay. So we easily know that this graph will look like this just by knowing one side of the graph. And you guys know that the point is here, here, and there, right? Because, and now we're gonna do the negative sign. Negative, when it's -1, it's undefined because the vertical asymptote is undefined, and when it's -2, it's -1. When it's -3, it's 0.3, about here, right? And this one, we easily know that it will look like this because it can't cross over. It can cross over the y = 0 because it's a horizontal asymptote. Okay, and this is our final graph. And now we need to focus on this behavior, because on the test, like, higher chance that we need to explain what these are. Non-permissible value. Okay, let's start from non-permissible value. What is a non-permissible value? It's something that we can't make, so it will be eventually 0, right? So we don't want that. That's why it's non-permissible value. So for non-permissible value, you need to look at the graph from the very beginning. So even before we canceled out stuff. What this means, you guys know, like, the very first time when we, like, cancel stuff, you guys know there was x minus 4 over x minus 4 times x plus 1. So NPV, non-permissible value, is +4 and -1. +4 and -1. This is because when we have +4 or -1, it just doesn't make sense because 0. It will eventually equal out to 0, so we don't want that. Okay, NPV. BNPV. What does BNPV mean? Okay, let me just erase this because we don't need it anymore. You guys can always go back to the video and review, right? Okay, BNPV. It means behavior of non-permissible value. What this means is that you guys need to focus on what the x is equal to. So basically means when x approach to 4, look at this graph. When x is approaching to 4, 4 is here. What does happen to y? So that's our question. Like, what does it happen when x is approached to 4? Then the absolute value of y will be equal to, it's very simple, just plug this 4 into our simplified value of the equation. Okay, what this means, okay, y = 1 over x plus 1, it was our original value. If I plug this 4 in here, it will be 1 over 5. Right, 1 over 5, which is 0.2. Y will be 0.2. Make sense? Okay. Now, is this our answer? No, we have one more, right? So we have one of this here. And also when the x is approaching to -1, our absolute value of y will be equal to, just plug in it, same thing. You guys can technically plug into this original value, but it's just more work, so I don't really recommend. Just plug it as in the simplified form. -1 plus 1 equals, if you plug into calculator, it will say math error. What this basically means, when its axis is approaching to -1, what happens? It goes up, right? So it's basically infinite. That will be our answer. Positive infinite. You guys then probably wonder, then, what about this one? This is negative infinity. What do we do? This is the reason why we have a absolute sign here. which is positive. Okay, makes sense? Okay, now let's look at the endpoint. Endpoint is when x is infinity, what's our y value? Very simple thing. Think about our vertical asymptote and horizontal asymptote. -1 and 0, right? Endpoint is always when x is infinity. Then y is value of our horizontal asymptote, which is 0. So this will be our answer. We don't even need this absolute value sign because we have an exact value of 0. When x, there should be absolute value for x. And this is our endpoint and x-intercept. Let's look at x-intercept. Y is equal to 1 over x plus 1. Quickly just solve this. Plug y into 0. There's nothing. So x-intercept is 0. Sorry, one more time. So x-intercept is 0. And then y-intercept. Y-intercept is very easy. Just plug 0 into the equation. You can do it in the original equation or the simplified equation. It doesn't really matter at all. Just 1 over 0 plus 1. It's 1. Okay, y-intercept is 1. Domain. Domain is always when... Oh, sorry, I wrote this up. X can be. X can be what? So you guys need to think of domain as looking at the original graph one more time. Where's original graph? Plus 4 and -1. You guys know that MPV in this domain has the same value? Yes, right? And also, let's add vertical asymptote and horizontal asymptote here because we need them in order to find this domain and range. I'm gonna use different color pen. The reason why I'm doing this, it shows that they have the same thing. What does mean by this range? Y can be horizontal asymptote. Or what's horizontal asymptote? It was 0, I believe. Yeah. Y can be 0, and we need to add behavior over NPV, which is 0.2. As 0.2. My way are so dry. And y is all real number. And x is all real number. POD, point of discontinuity. This behavior, POD, has the same value. So what any 2 points that we have exactly the same, this one, 4 and 0.2, is our POD, vertical asymptote. We knew that vertical asymptote is -1, horizontal asymptote was 0. And here is our final value of this question. Let me just erase all the unnecessary part. Okay, so here is our final value. One last thing, you guys know this POD here? 4 and 0.2? 4 is going to be here and 0.2 is going to be here. So this part is our POD. Okay, and this is our final graph visualizing. And yeah, thank you for watching the video. Yeah, this is our final graph for fx is equal to x minus 4 over x squared minus 3x minus 4. And this is our final graph. Thank you for watching the video, and comment below if you guys have any questions. And okay, thank you and see you.